One of the ways in which the human beings can go on to play a significant role is by creating an ozone hole. Now, with respect to ozone hole, our concern will be something like, one of them will be, the question that can be asked is, there can be an ozone hole over Delhi. Yes or no? Why? I said the same thing some time back, and you went to answer me back, but give me a reason. If you have to give any answer, give me with a reason. I'm going to give my reason. Sorry?
Reaction can take place only.
From okay.
Ozone reaction, Cl plus O3, that can take place only on colder surface.
Only on colder surface. Okay, listen up to that part. Why is it possible over Delhi? Why is it not possible over Delhi? And keep on finding reports that is that over Bhopal there is a big ozone hole. But you will keep on finding such type of reports. You will come to know about it. Journalists keep on writing these things, but then their poor people hardly have any information. They haven't gone such type of a extensive course discussion or maybe coaching or training or anything like you are now. Now, understand this entire process, and there will be some of these questions that will be asked to you from mechanism of ozone hole, and the second will be its impact. Ozone hole is essentially destroyed with the help of two processes. One is the use of the CFC, and other is because of the stratospheric jets. That is, the jets which go on to leave their contrails. That is, condensation fails in the stratosphere. Stratosphere is a good place to fly your aeroplane because the atmosphere is stratified in this case. Because it is in this space that the atmosphere is in static position. It's in this space that you don't want to find high velocity winds. Because in this space you don't want to find atmospheric turbulence. Because it is in this space that you don't want to find any type of weather phenomena at all. And in this space, the whole of this atmosphere is made of several layers. It's the best place in the entire of the universe to fly an aeroplane. Consequently, people will always be looking for flying an aeroplane in these type of regions. Always. When these airplanes go to fly, they're going to leave a condensation trail. That's called as contrail. You may have observed sometime. When the plane is going to fly, they're going to leave a trail of vapor behind. That's called as condensation trail or contrails. That's the name given to it. So, two of these processes they go on to be releasing a good amount of NO2, and this NO2 will go on to be combining with the O2, that will go on to include nitrogen monoxide plus O2 plus O. Maybe plus O2 as well. So that is how exactly the ozone is going to be broken. Now this is the basic issue. This is the basic issue why we are generally against allowing any type of an aeroplane to be flying in a stratosphere, because they go on to play havoc with the ozone layer. And ozone is formed in which zone? Ozone is formed in which zone, and where exactly it is concentrated? Where exactly it goes into form? Something is wrong. Ozone goes on to form in the thermosphere, and after having been formed in that, it goes on to sink to stratosphere. that zone of the stratosphere there is going to be high concentration of ozone is going to be called as ozonosphere. Chemosphere is one of those layers where the chemical activity is most well marked. One of these layers of atmosphere which is known for its chemical activity every time is called as chemosphere. So it can be because of ionization, it can go on to be because of certain type of three-body collisions, it can go on to because of the breakage of some of these type of molecules into atomic oxygen and a variety of other forms. That is one mechanism, simple mechanism. And that is the basic controversy regarding whether we are going to fly the Orient Express in these zones or not. Orient Express is what? Is one of these type of hyperplanes that are being developed, and that will go to fly the stratosphere with a distance between London and New York will be covered in just 2 hours flight. That is it. So one of these aeroplanes that used to be flying in the stratosphere now has been phased out. That is Concorde. It was Concorde. There was a Russian aeroplane as well, but he couldn't go to take it off itself. That was Tu-144. So 2 of them that have been there all in all. Most important of this mechanism has been associated with the use of the chlorofluorocarbons. Now CFC is going to be used in a variety of type of products. For example, this gas is a minefield of CFC. All the air conditioners going to be using it. Any one of you who don't have, may not have taken a bath and you have come with a deodorant, you have used the CFC, right? Any one of you who have used the perfume have used the CFC. The tables have been cleaned with the help of a spray that also goes to contain CFC, right? All of these walls, the pins of this wall go on to consist of some amount of CFC, and so on, so forth. Supposing I go on to be using an aftershave. This goes on to be having a spray that will definitely go on to have some amount of a CFC, unless I go on to bring it from some place like that of Givenchy, maybe some of them like Davidoff, all of those type of French companies which are going to be fashion brands of sorts. So it can be Giorgio Armani, it can be Gianni Versace, it can be Donna Karan, it can be any one of them, right, in general. Otherwise, pure desi Indian brands will go on to have some amount of CFC. I have used it, thrown it out. After some time, this AC will stop functioning. We will have to throw them out. The compression will be throwing it out. And if there are going to be some shaving gels that may or may not have it. For example, of course, some of the shaving gels like that of Gillette, they don't want to be using CFC at all. They go to make it very clear. That is the way they go to sell their products. But some of them will go on to use it. So we have thrown it, and they will start releasing this CFC back into the atmosphere. One single chlorine item will go on to take no less than 25 years of a time to reach to the top of the troposphere. That means that whatever may have been the amount of CFC we may have produced sometime in the past, this CFC will be able to reach the atmosphere, particularly stratosphere, only now, if at all they are able to reach it. If at all they are able to reach it. Okay? They will not reach it because the troposphere on the top has a temperature inversion lid. It goes on to be having a cover, temperature inversion cover on the top. And this temperature inversion cover that is on the top will go to prevent any type of a mixture to take place between the tropo and the stratosphere. So every type of a chlorofluorocarbon will go on to remain only in the atmosphere, in the troposphere. It will not go on to mix and match with the stratosphere in the place where it is being produced. Is that clear? So Delhi can't go to have an ozone hole. Simplified. The top of the troposphere goes on to behave like that of a lid, a cover. Understand this concept? It's called the tropopause. It's called the tropopause. Made more properly dhakkan, not to you, but to that layer. Right? That is the lid, the big cover that we're going to be talking about. So why is it that an ozone hole will be created at all? The entire of the Earth's atmosphere goes on to be in some degree of a turbulence or the other. It has some degree of a turbulence. There are some high velocity winds that keep on blowing. We will go to observe that, and that is again a practical observation. And as we are going to say, that everything that we are talking about in the class, practical, theoretical, is going to be helpful for your brains. There is so much amount of pollution that we have spewed into the atmosphere of Delhi. Why is it not that these pollutants going to accumulate to an amount that goes on to be of unimaginable proportion? Why? Because they are removed by high velocity winds. Some of these high velocity winds go on to be called as jet stream. So jet streams that are responsible for cleaning the whole of Delhi. They keep on cleaning it. Again, you are going to find an example of it. Delhi is going to be very foggy, it's going to be very murky condition somewhere in the winter season, November or December. All of a sudden, you are going to find that the air starts blowing and the whole of Delhi goes to become very neat and clean. That means the jet streams are blowing over Delhi and they have lifted all of these pollutants, they have transported it somewhere else. Right? A question was asked that you're going to find this surprising. There is when you go on to be moving from Guwahati towards Delhi, then near to about Delhi, you're going to encounter a great amount of turbulence during the winter season. This turbulence is caused by A, B, C, D, 3, and so on. 1 and 2, 2 and 3 is caused by jet stream. This is caused by jet stream. That's the reason I'm saying there is understand this part, understand this component. It goes on to be a great amount of a practical connotation. And what we are saying is, there is if someone is moving from Guwahati towards Delhi, then that is how the jet stream is going to be moving. This is the way the jet stream is going to be moving. What most of these pilots will going to do is that they will not going to allow their planes to be moving into jet stream against the jet stream. You will go to observe that sometimes it may go to take you 2 hours or 3 hours of time from Guwahati to reach to this place. And from here to here, it will be half an hour less. That was again another question that was asked. And that is because of this jet stream, they are going to blow at the speed of 240 kilometers an hour. So these jet streams are able to clean it. Now these jet streams go on to blow through the whole of the Earth. In the polar areas, the troposphere in the winters is very, very, very thin. You may have known this part. That's my assumption. A good number of my assumptions have not been correct by and large with respect to you. This also may not be so. There is in the polar areas, particularly in Antarctica, how much is the thickness of the troposphere? I am saying in winters. See, I am asking these questions more because sometime back I was asking 1, 2, I found one of them wrong, second was wrong, third was wrong, fourth was wrong. So I think that is I have taken this mantle, despite the fact that a good number of you may not going to like it, but then that's my habit of reforming you. I am basically a reformer, not a coach. So that's the reason I am asking this question to you. How much is the thickness of the troposphere in the winters in Antarctica? 5 kilometers? Sure? Who said that? Sure? That's the problem. It's only 1 kilometer. I'm talking about, I said winters. In the summers, it can go on to be 8 kilometers. In the summers, it can be 8 kilometers, but in the winters, it can be only 1 kilometer, and sometimes the entire of this troposphere can go on to be absent as well. See, your question is very valid, that is in summers and winters it is going to be why it is so, but if I go on to pick up this topic, I will go on to land myself in a complete topic of physics. I don't have a problem, but then this complete ecology, you accumulate all such type of questions you have. One of these days, I will go to discuss it out. Happy? To an extent, polar vortex is a result of it, not exactly cause of it. It's because of the jet stream. It's because of a very peculiar nature of the air circulation taking place over the region. Now, what happens in the polar areas then? This is your part. This is your Earth. That's where Antarctic will be. Now we are going to be making a diagram with respect to Antarctica and going to be reversing it. I'm not going to do that in Antarctica. I'm going to make the same thing in Arctic. Why? Because if I go to make a diagram in the Antarctic region, then you will have to do a session today itself instead of tomorrow to take a look at it. I don't want this to happen to you poor people. Right? That's the reason I go on to draw that on the top. That is the type of a circulation that you're going to be having over Antarctic. Consider for a moment that it's going to be Antarctica. And over Antarctica, you're going to be having one cold polar vortex surrounding which is going to be a jet stream. This is going to be called as a polar stratospheric. It's polar night. Stratospheric jet stream. It's going to be polar night stratospheric jet stream. And this polar night stratospheric jet stream keep on hovering above Antarctica. The movement is, if you can go on to watch my hands this way, if you can go to, this is going to be in the polar regions in this line, it's in the form of a vortex. Keeps on moving in this region, keeps on moving up and up and up. That is a vortex type of circulation. Circulation can go to be linear, circulation can go to become wavy, circulation can go on to become a spiral, that is jumping over a wide number of latitude. Circulation can be in the form of a vortex, right? So air circulation can be of variety of types, and this is going to be one type of an air circulation taking place over Antarctica. Now, what has happened is that all of the chlorofluorocarbons that we went on to produce, where? That is in India or anywhere else in the whole of the world. They have got themselves mixed with the air and they have been transported and dispersed throughout the whole of the earth. So good number of them have found their way towards Antarctica as well. That is in the summer season in Antarctica. So they are going to be found there. In the winter, the whole of this troposphere starts becoming shorter, and then a time comes when the upper portion of the tropopause goes into breadth and goes into mix with the stratosphere. So there is only, that is the center of the length of it goes on to be only of the stratosphere, that is of 25 kilometers of a length. That is the entire of the column is going to be 25 kilometers. Now, will that have chlorofluorocarbons now? Yes, because they have been distributed and dispersed throughout the whole of the earth. So they will go on to have a good amount of chlorofluorocarbons in this region. Okay? So are they going to be having good amount of chlorofluorocarbon? Then these chlorofluorocarbons will go on to now be, they have been by and large locked in this air, locked in this vortex. This vortex will not go to have any type of, contact with the surrounding layer. It will go on to be completely isolated. And once it has been there, then the CFC have been locked, and inside it the temperature will keep on dropping, keep on falling, keep on falling. So by the winter's peak of this winter, that is tomorrow, that is 21st of June, Antarctica will be having a peak of its winter condition. So under that condition, that will go on to lead to formation of clouds of ice crystals. And over these ice crystal clouds, CFC will go to deposit itself. It will go to start resting. And throughout this entire of the winters, beginning from 22nd of March to 22nd of September, the build-up of the CFC over the ice crystals will keep on taking place. So now what has happened is, that is in Antarctica, in this region, the temperature is very low. There is a polar vortex. There is no troposphere. It's only stratosphere. And there are going to be ice clouds. And over ice clouds is present CFC. After September, after 22nd of September, some changes start taking place. These changes that start taking place, these changes go into one of them is that on 23rd and 24th of September, the first of the rays of sunlight going to strike the region. As the sunlight goes to strike this region, then ice crystals will start melting. As these ice crystals, which have locked in good amount of chlorofluorocarbon, they will start melting. As they start melting, they will go on to release this chlorine into the atmosphere. Okay, and the atmosphere now is it troposphere or stratosphere only? It is only stratosphere. Troposphere will go on to build up by after 3 months of time. That is, troposphere in this place is going to be completely absent. On 24th of September, all of a sudden troposphere is not going to come. It is going to be stratosphere. That is the type of suppression we are going to be having. So this chlorine will go on to come in contact with O3. That will go on to lead to formation of a chlorine monoxide plus oxygen. Ozone has been broken. Then in the third of this reaction, chlorine plus oxygen plus oxygen molecules. In the fourth of this reaction, that is chlorine once again, it goes on to pick up another ozone, and then again it is going to be chlorine monoxide and that of O2. This is a chain of a reaction that will start taking place. So this will go on to become a chain of a reaction that will start taking place soon. And as this starts taking place in this manner, as it starts taking place in such a manner, then one single chlorine atom is responsible for a breakdown of more than 1 lakh ozone molecules. Ozone will be destroyed. That is the mechanism of the destruction of ozone in the polar areas. And why only in the polar areas? Because the formation of this vortex. And which is the one air stream that is guarding this vortex? That is jet stream. That's the basic mechanism. Now it is in this condition that of course the concept was a bit extended, maybe 10 minutes of an extra time that we have taken. You may not have required to know all of those things, but then concepts are like that, you're going to live in between and you're going to be completely blank. There will be some of these type of topics like this one, where you don't require to understand it in such a manner, but unless you understand it, you will not be confident of answering a lot of questions out of it as well. So we have answered 3 things out of it. First, there is a stratospheric polar night jet stream, number 1. Secondly, there is a vortex type of circulation in Antarctica. The third is that the entire of the height of where the troposphere in the polar areas is very low. The fourth is that all of this wind circulation finds itself circulating the CFC anywhere in the whole of the world. The fifth is that there is going to be an ice crystal cloud which the entire of CFC is going to be deposited. and the reaction is going to be comprising of chlorine monoxide plus ozone. You never know what kind of all that can be asked from you, because this is a conceptual topic and chances of it being asked in the form of a conceptual topic is always very high. Not every question is going to be completely application based. Questions are going to be, maybe except for one or two questions, all the questions are going to be conceptual based, explanation based, observation based or application based. And only maybe one or two of these questions can be fact based. Is that clear? Thank you for understanding. Now, our concern is what is the likely impact of the depletion of ozone on the whole of the Earth. That is our concern. And if there are going to be maybe some 10 impacts, let's say 1 to 10 impacts, then we are not going to be taking all of these impacts. We are going to pick up only some of these impacts, maybe only 2 of them or 4 of them, because the rest of them will going to be in the form of a fact. You have to know that. We are going to pick up only those of them which will going to find it difficult to understand on your own. Why is this happening? Where the question involved is why, right? And then that's the scientific, that is the spirit of a scientific inquiry, because we are always trying to answer this question why. If it is that we are trying to be answering this question how, that goes to become descriptive. Right? We are not making descriptive, we are making it scientific by answering this question why.